Hello guys, I hope I'm audible and visible, before we start with the greetings and everything. So can you confirm that? Yes, yes, yeah. Thank you guys. Thank you for the confirmation. So I welcome you all to the this week's OdinTalk live session, and so which we will be discussing about applications of data science related to fraud analysis. So as you know that the topic is an interesting one, so which you can find, the various kind of aspect where you will be analyzing all these kind of things, fraud related to fraud and everything. So, and yeah, and just now our speaker has joined. So, which is good evening, Somnath.
Hey, good evening, Srinivas.
Yeah, hi, hi, good evening.
Yeah,
So, could you turn on your
yeah.
webcams?
Just give me a second.
Sure, sure.
That. Oh, am I not audible?
Hey, you're audible. You're audible. It's perfect.
Okay. So somebody said I'm not audible.
No, no, we are audible. I guess, guys. So, if anyone are facing such kind of issues, please make sure that your internet connectivity is good and your audio checking also. Yeah. So we have our speaker Somnath. So who is a senior manager at AB InBev. So he will be guiding you about today's topic, application of data science, which is related when it involves fraud analysis. So, so please, guys, make yourself engaging in this session and put your utmost interest and effort. Yeah, over to you so much, so you can continue.
Sure. Thank you, everyone, and thank you, OdinSchool and Srinivas, for giving me a chance of talking to you guys. Let me before we okay, no issues. Srinivas already answered that.
Yeah,
Let me introduce myself first. Let me know if my screen is visible.
perfect. Yeah, your screen is visible. Yeah, you can go ahead.
Yeah. Okay. So okay. As Srinivas told that I am currently working in Wave as a senior manager data science, but this is how my journey started. And purpose of this session would be I don't want to be more like an technical in terms of just to go into the deep of technical things. I wanted to give you a little bit of clue that how exactly the industry, the use cases works. So that my purpose. Hopefully that will be useful. But before coming into that, let me introduce myself that I completed my MSc Computer Science back in 2010 from Banaras University. Then I joined Cognizant. With first 2 years was data engineer, then moved into the data analytics team inside the Cognizant 2012. Then till 2014, I was working as a data scientist or maybe data analyst, I would call that time. Not data scientist was not a fancy name at that time. Moved to RS Software, the similar role. First 5 years, I was working into the banking and financial, and that's where this fraud analytics is coming from. That time, we used to solve a lot of this kind of use cases. And then I moved. I was thinking that doing that the only the BFSI domain. I was working on that. I wanted to know that how the analytics is working into different other domains as well. So I that time Praxis was giving me a business analytics kind of courses. So I did the full-time education to just to understand how the business for the other domains are working. Then I worked NPCI, Gramener, HP, VMware, and currently I'm working in Avian if you don't know about Avian Web is a company, beer company. So not sure, but you probably heard of Budweiser beer. So that's the parent company is Avian. Okay, so that's about this one. Let me move to the actual fraud detections part. Before even coming into the fraud detection, just wanted to understand from you, and let's make it as a little bit of interactive if possible. I'm not sure you guys can. Yeah, I'm not sure you guys can chat and answer me into this, but I want a little bit of answer if possible, not very mandatory kind of, but let's do that. When saying you guys that fraud detections from the data science perspective, forget about the problem. Data science perspectives, what kind of problem you guys think of? Any one or two answer? Transaction investigations, duplicates, wrong entries. SMS fraud. Okay, that's any fraud detections. No domain. Think about uh, fraud. What I'm going to talk about into this is the account hack kind of fraud. That okay, your account has been taken. Like for example, your Gmail account has been taken by somebody, or maybe some other accounts has been taken by somebody. Yeah, credit card. All of these things are financial fraud. I'm talking about little bit of similar kind. But think from the data science perspective. Okay, let me ask you very specifically. It's a classification problem or it's a regression problem? Any answers? Great, classifications. Yeah, great. Let's move to the actual. Before even coming into that, these are the things we'll discuss. We'll talk about what exactly we're going to discuss about this fraud, what exactly the problems comes from, and you will understand how the actual business use cases works into the industry. That where your client or your stakeholder will provide you some details about their current work, and you need to dig down and you need to find out actual problem and solve it through the data science. Then first task comes down to that data exploration and understanding. Your client will not help you. It's all about you. You need to do your data exploration and understanding part. Then coming into the data processing, EDA, we'll talk about little detail into this. Then finally comes down to the architecture and the model selection. As a data scientist, this is where your maximum of the value addition comes. How you will structure your model architecture, how you are going to utilize that end-to-end model architecture and create a end-to-end pipeline for your client or for your stakeholders. Problem of skew data, that I think somebody has already answered this one into your chat, that wrong data probably and one-sided data, something like that. That we'll discuss about this one. And robust model validation. You guys probably aware of that what bias data model validation is. Then finally, you build the data, build the model. Your task is not done. How your client or stakeholder or your user is going to use that particular model, how you are going to create this robust system end to end, then it will become useful for your client. You created some model, you deliver something, it's useless until unless you are creating a proper deployment or monitoring strategy for your client. This is the problem. So this is actually a one real time issues or real time problems I faced. Although I anonymize everything, but real time problems I faced where the stakeholders or the client we received, they were already having one fraud detections, but it was kind of a rule based fraud detection. That okay, this is happening, there is fraud. This is happening, there is non fraud, something like that. But it was not giving maximum of the accuracy. Okay. I think, okay, will you teach us how to detect the fraud in data? I can tell you within 1 hour, definitely it's not possible to teach you how to detect the fraud onto that. I can tell you a overall structure of fraud detections problem, how end-to-end can be happening. It can help you to solve any similar kind of business problem. In the end, we'll discuss about uh, what kind of problem can be similar to this particular problem. But I think when you will end, the last 10 minutes probably will discuss all about this one. Yeah, we are. I'm not talking about any machine learning model this time. I'm just talking about the business problem. So think about our client came that they are having a rule-based model where people are saying that okay, if there is some transaction happening or there is some fraudulent kind of transaction happening, I'm marking them as fraud. If not happening, I'm not marking them as fraud. So this kind of rule-based were happening, but it was not based on any statistical or machine learning model. It is only rule based. So obviously their accuracy was not that good. Maintenance was very cumbersome because they have to maintain that rule, they have to do that, and that's all. Then coming into the there are a lot of changes were coming, and they have to maintain their rule or they have to change their rule every frequently. So our purpose of this particular project was increase the accuracy. So obviously they were getting approximately 50, 55 accuracies. That's not good enough because that's like an just a coin toss, right? That you are having a head and tail, and you have two of the sides, and you are tossing, that 50% chance that you will get a head, 50% chance you will get a tail. So that's 50% of accuracy is similar to this. So that was not good enough for them. Reduce the false positive. I'm not sure you guys are aware of what do you mean by false positive. Means I'm saying that it is non-fraud, but it is actually a wrong non-fraud. That means it is a fraud, that kind of thing. Enable the preemptive detections in terms of that before the even fraud is happening. It's not, should not be a rule based that after the fraud is happening you are saying okay this was fraud. That's not that much of useful. You need to tell beforehand whenever the fraud is going to happen based on the certain pattern. We'll talk about what pattern. So this is the data we receive. So let's I'll take probably okay, I'll take probably a little bit time to give you guys that 2 minutes. Just go through these names, and in the chat write any of the names where you are not able to understand. If I'm going through all the names, probably it will take 10 minutes, 15 minutes only to go through the data. But just go through the names and write in the chat. I will explain that particular names. But just to give you the background, this is the data we received from historical fraud case list, customer information on the table, call history. So people are calling to the call center and saying that, okay, this kind of fraud or this kind of security issues I am facing, and customer feedback regarding the call history. Account change history. They were changing some account. They were changing the names. They are changing the okay, communication transcript. Good question. Communication transcript means that when you are talking to a customer care, that particular communication is being recorded, and that recorded is converted into text. And that text, you can actually analyze that text and find out something from that text you can use into your machine learning model. That's the communication text or the transcript. Timestamp is simple, that at what time that particular customer called, or that what time that account change history happened. Every particular data, almost every particular data will have timestamp, only the customer informations, because that's a static kind of data sets. Other than that, when the call history happened, when the customer called, how much time the customer called, all these things are timestamp. Yep, ML is about numerical data or categorical data, but we are talking about text. From the text, you can actually find out the numerical data points or categorical data points, and you can apply your ML model as well. Very difficult to consolidate into this 1 hour of time, but we will try how to do that. What do you mean by fraud category? Yes, fraud category can be happening. It's like somebody has sent some SMS from your account. Somebody has sent an email from your account, or somebody has done some financial transaction from your account. That kind of fraud category. Communication transcript. Now it is clear. Okay, great. I think we can go into the next part. And last about the different problems solved at avian web. Okay, we'll talk about avian web part later. Change type, change reason, change status. Okay. Think about somebody has changed something into your account, Gmail account is name. So that's a change type of name change. That reason can have, okay, you mentioned that, okay, that change of the reason is maybe you doubt that somebody is trying to hack, or you change something because of some personal reason or something like that. Change status is that change may not impact you directly. That can change, it can effective after some time. So that status will be shown there. Customer feedback is normal customer feedback. You provided some customer feedback to any of the accounts, right? So example, there is an Amazon account and you call them and there is a customer feedback comes. So that's the customer feedback. Okay, let's go into the data pre-processing. Lot of text. Let's not go into each of the text, but I will tell you that the bullet points, and we can talk about a little bit into this. So think about that data pre-processing. What kind of data discrepancies you may face? I'm a little bit entering into the machine learning part, but don't worry. If you are seeing that more technical or you are not able to understand, please ping me in the chat. The chat is already open side by side. We can talk there. So yeah, missing data, skewness of the data, something missing. I don't know what that means, but yeah. So missing in the sense it can have uh, missing data in terms of that, okay, you are having example into this, that change type. You are having all the change time. Suddenly you saw that there is no change type for particular data. Maybe because of some system problem or something like that, it blank. So that kind of missing data. Yeah, null values, wrong data. Yes, wrong data, null values, those kind of. So that's the data discrepancies and data quality issues I'm talking about. So those things we need to remove. How we need to remove? This is more like a business to discuss with. That you cannot directly remove any particular data discrepancies based on your understanding. You should discuss with your business that, okay, this data discrepancy is valid or maybe something wrong in the data. Yeah, you can replace, you can actually impute. There are a lot of different technique to impute your missing data, but theoretically you should not replace some missing value where maybe 10 more than 10% are missing. But that theoretical. In practical world, that varies. Sometimes you may not want to replace your, even it is 6% missing. So that we need to find out based on the business to business. We can use imputations. Yes, we can use imputation. That's exactly I talked about. You can actually apply some of the machine learning algorithm to impute your missing values as well. If you guys are using R or Python, there are packages called mice, M-I-C-E, that has lot of missing value imputation technique. Yes, KNN imputer is also, KNN is one of the algorithm, right? So you can actually apply and predict what is will be the missing values. Yes, statistically missing. Okay, moving ahead. Now going into the feature selection or feature engineering part before. As somebody pointed out that machine learning algorithms only understand numerical. Very valid point, but you may not get all the numerical values, right? So you need to convert those categorical values or the text values into numerical values. Example, you are seeing that there is an written as fraud, F-R-A-U-D, fraud. That's a categorical value. But can I convert that fraud into 1 and non-fraud equal to 0? That's a numerical variable. That we call in the very technical or jargon language is the one-hot encoding. That is nothing but you are converting into 0 or 1. Yes. Feature scaling. Scaling is a technique where you are talking about, example, that you are having lot of outliers into your data. You are having lot of different type of outlier that, okay, one transaction is happening 1 CR and another transaction is happening 20 rupees. So that kind of variation into the data, machine learning model sometimes unstable. Sometimes I'm saying these two things. There is no written rule or thumb rule that you have to scale certain type of data. You need to, as a data scientist, and that's where your skill set comes, that you need, as a data scientist, you need to understand that where the scaling is needed, where exactly the feature engineering is needed. And there are sometimes back and forth with your modeling and understanding that where exactly those things are needed. Yeah, like high magnitude and the low magnitude, as I give the example, the 1 crore versus 20 rupees, something like that. So that kind of scaling we should do. Otherwise, machine learning model, if you are applying, or even statistical model, if you are applying, it can be very unstable. It can give you a particular result, but the result may not be stable. Next time you will apply, it can give you a different result. There are logic behind it. I'm not going into that depth, but there are logic behind it why it does like that. But that feature scaling comes into that picture. Okay, we'll talk about the ML model and statistical model. There is a lot of debate onto that part. Let's skip last 15 minutes or maybe 10 minutes to discuss all these things which are not regarding to fraud analytics. We'll talk about that. Let's not divert. Now coming to the target variable, as I talked about that, fraud and non-fraud. This is very subjective. That when you are calling something as fraud, when you are calling something as non-fraud, that coming from your historical use cases, but this may not be defined like that. Somebody has said that, okay, if you are saying that this kind of transaction is happening, and then only I'm calling this one as fraud. If you are saying this kind of transaction is not happening, then only you are coming as non-fraud. Then this fraud and non-fraud is definition specific, and you need to define what you want to call it as a fraud and what you don't want to call it as a fraud. So that's why the target variable definition is very important. And this is not only fraud, there are maximum classification problems where you have to define your target variable. It's not very straightforward. Okay. Now coming into the EDA, exploratory data analysis part. This is kind of your, I will call it as a door to your machine learning algorithms. Ideally, you should not jump into any kind of machine learning algorithm or statistical algorithm before even doing any exploratory analysis. The reason behind is you may end up applying some algorithms which are giving you some good result, or maybe which are giving you some result by fluke you are getting, and may not be sustainable, may not be stable. So that's why to understand the data, exploratory data analysis is very, very, very important. Feature importance, you have this many of features. Do you want to just dump all these features into your algorithm? You should not. So to identify what are those variables are important for your algorithm, feature importance or feature selections process is also part of your exploratory data analysis. Identify the data trend. Example, I will take an example of maybe COVID cases. Everybody is aware of that from 2020 till 2021. Sometimes COVID cases was increasing till 2020 end. Then suddenly it got decreasing. Then suddenly it got increasing. So that's the trend it followed. So that kind of data trend we need to find out to apply, or we need to apply a certain type of algorithm. So that's why the identify data trend is very important. Specifically for sales data, specifically for transactional data, data trends are much, much, much important thing before you apply any kind of algorithm. If you are blindly applying something, then it may or may not work. It will be very unstable. And ideal cases, all these things are processed. Coming to data anomalies, I gave you one example that 20 and 1 is coming as 1 crore. So think about that. If you are in your UPI account every day buying a milk packet from your nearest shop, and every day you are doing some transaction of 40 rupees, 20 rupees, 40 rupees, 20 rupees. Suddenly one morning, there is a transaction happen of 1 lakh. That's data anomalies that we need to uncover and see why that may happen. You cannot directly call it as a fraud. Maybe you at that day you travel to somewhere where that 1 lakh rupees, or maybe you travel to some hospitals, or you may travel to something, some jewelry shop, and you bought something which is actually 1 lakh rupees. It may not be fraud or may not be anomaly. So those kind of anomaly detections we need to do, and we need to justify with the data why it is happening, or maybe it's a data problem, or maybe it's a fraud. So those kind of trend we need to find out. I'll take a pause, maybe 1 minute, just to see in case you have any questions. Data pre-processing, I just explained. This data discrepancies, missing data, data quality issues, data integration issues, or any data related issues, not the explorations, but any data related issues you are having, that to identify is that the data pre-processing. Identify and fix it if possible. Which method we find data anomalies? There are a lot of different algorithms. Data anomalies is a totally a different subject. I'm not going into that part, but we can discuss in the end. How to find fraud, missing data? Could you provide this slide to? Okay, I already provided that slide to OdinSchool. I'm not sure we can provide probably. But this is totally anonymized data. I don't have any problem to provide this one. Missing values in data. We discussed this one, but let me repeat how to fill the missing values. There are a lot of different areas. Think about that you have 100 rows and 90 rows has the data and 10 rows are missing values. Can I take that 90 rows as my trend data and try to predict my another 10 rows? I can do that, right? So if I can predict that, I can actually fill those missing values, fill those 10 missing values with that 90 rows to predict that 10 rows. That is one of the way. Mean, mode value, those are fine, but those are kind of a basic. But if you have more missing values, you need to go into a little bit of depth. Okay, which one is good practice? Missing values? Yeah, as I told, that there is an kind of a theoretical rule that more than 10%, or somebody says more than 6%, there is no thumb rule that this is the percentage. This is the percentage of cutoff you should take. But generally, we take 6 to 10% of cutoff. If more than that, we generally don't go into the missing values. We generally remove those rows if that is a very important variable for you. If that is not, we can remove that particular variable. Sorry, there too many of chat. I missed one bigger one. If the output variable is categorical, which algorithm variable is suitable? If output variable is continuous, then which? Okay, you tell me. I'm keeping this chat for you. You tell me. I think you guys already answered this one, but I'm just copy pasting this one from my side. You tell me. Okay, this is very good question. Which method do you use to calculate the missing values? Median or mean? It's really depends, sir. One is that if your data is too much skewed in terms of same example, that if you are having one transaction as 1 crore and one transaction and back all the transaction are 20 rupees, then you should not use mean, because your mean will be skewed. So that's why you should not use mean. But in that case, you should use median or mode. Mode also not, because your mode will always be 1 crore, right? Then in case then median. But if your data is properly distributed and every transaction is between 20 rupees, 25 rupees, 30 rupees, something like that, in those cases, you can use mean. Yeah, right skew, correct. Okay, answer to that above question. I'm not sure you guys answered that one or not. If you are having a kind of a categorical variable as your target, like a 0, 1 or ABC or something like that, then it is a classification problem. So classification machine learning problems, there are different kind of machine learning algorithms, starting from logistic regression to random forest, decision tree, etc., etc. In kind of regression, linear regression is the starting point. Everybody start with that. It's a numerical target variable. If it is, then you can apply random forest again. You can apply decision tree again. You can apply SVM. You can apply KNN. There are hundreds of algorithms. Different ML algorithms are normally having regression and classification both. For example, decision tree, random forest, neural network, all of these things, they support numerical or categorical, both kind of, although the explanation is different, but both kind of variables. Okay, I'm moving ahead. We'll probably take more questions in the end, but this is the common skew problem for any kind of classification problem, specifically if you are having some similar to the fraud detection. Think about it, that if you are having a maybe an UPI fraud, how many UPI transactions are happening in India? There are lakhs of crores of UPI transactions are happening every day, right? But how many frauds are happening? Maybe 1, 2, 3, 10, 100. You can probably count on your hand that how many frauds are happening. So if I'm counting fraud versus non-fraud, there are hundreds of thousands of lakhs are non-fraud. Frauds are probably 10, 20, 100, like that. So that kind of skewness you will definitely get in your data. It's very easy to find out the skewness. I got a one question that how can I identify? The example I provided, even you don't need to understand any kind of data science to identify. If I'm talking about any specific places, any stable specific places like UPI or maybe credit card transaction, the non-fraud will always be higher, much, much, much higher than your fraud cases. Because think about, if you are having more fraud than non-fraud, who will do the transaction? If you are already aware that your UPI transaction, there are 100 of transaction happening. If you are doing 200 of 100 of frauds are happening, if you are doing 200 of transactions, then you will not use that API, right? The API, right? So that's why the all this kind of processes, the fraud cases will always be much lower than your non-fraud cases. This is the skewness problem. Now, how to handle this skewness? that what should we do, and what will be the problem if I'm applying skewness, this one. uh, think a machine learning model as a human psychology, right? That if I'm asking you that, do you trust UPI transaction? You'd say yes. Uh, I would ask you that if you are going to going to a market and do a transaction, what is the chance that you will be attacked by some hackers and your UPI transaction will be fraud? You would say that no chances. I will always be, there will not be any fraud. I totally doubt. But is it a zero chance of fraud? No, there is a probably 99.999% chances that you will not be fraud. That will not be fraud, but there is at least some chance that there is a fraud. Machine learning model or any kind of model works into similar kind of mindset. Neural network came from our mind, right? So that more and more data you will provide into a certain type of class, it will more and more, it will be convinced that there will not be no fraud. Exactly, I'll give you probably 10 seconds to think about it. That if you are, as a human also, if I'm giving you more and more data that there will not be any fraud, don't worry. You will convince 100% that there will not be any fraud. Exactly the similar situation happen if I'm applying with that data with a machine learning model. It will convince 100% there will not be fraud. That 0.00001% it will avoid. So that's the model biasness. It will bias towards non-fraudulent cases. So that's why we need something to improve it. What we can do, we can actually remove some of the non-fraud cases. Basically, I'm talking about undersampling with your non-fraud cases and show the model, look, there is some fraud cases. Don't see only the non-fraud cases. See some fraud cases. Exactly. Forget about model. Think about a human being. I'm removing some of the non-fraud cases and I will show some of the fraud cases to you. You will suddenly try to convince that, okay, there can be chance of fraud, right? So that's why that resampling is needed. Similarly, oversampling, that I will oversample some of the minority classes, basically the fraudulent cases, and I will undersampling my non-fraudulent cases and try to show the model, or in your example, try to show that human being that, okay, see, there are some fraudulent cases. So that's where model will start convincing that, okay, yes, there are some possibility of fraud as well. Let's try to think about it. So that's one. Second thing is model evaluation metric. That if I'm trying to find out evaluation metric, we'll talk about it in the later slide in detail, that some evaluation metrics are more biased toward your majority classes, basically the non-fraudulent in our cases. There are some evaluation metric are like SMOT, you guys already told in our slide, we already talked about it, synthetic minority oversampling technique. What I just talked about till now, I really did not wanted to use that name as a jargon because that will confuse you. That oversampling, undersampling, in our data science world, we call this technique or algorithm, call it as a SMOT. That is nothing but you are creating some data to make it oversampling or removing some data to make it undersampling. Okay, I'll take a pause in case you any questions. Too many of details. I tried to make it as simple as possible, but let me know if anything is not clear. Not large. Yeah, large sample means you actually repeat your current sample. So current non-fraud. Oversampling means you will, current fraud. Oversampling means you are actually repeating your minority class. In our case is fraudulent class. That is yes on your this one. Yes, that is a fraud. I will increase this particular bar. That is oversampling. May or may not. Sampling is a very tricky question. That's why I never use that sampling thing into our slide yet. The reason behind is if your data is possible to handle with your current system, current model technique, let's not go into the sampling technique because you may lose a lot of important factors there. If you're not able to find out, then you should do a sampling. There are a lot of different techniques of sampling you can do to do that. We know that yeah, AUC ROC curve, I may not able to go into that deep, but we'll talk about in the next slide. Comes at what point we know that the sample data comes in oversampling? No. Sample data doesn't come into oversampling. If you are seeing this kind of situations on your slide, the left hand side, that maximum no and very less yes, then you know that you need a oversampling technique to make this yes into little higher and this undersampling to make this no into little lower. It's nothing to do with the sampling technique. It's an oversampling and undersampling to make this bar little similar to each other. Yes, it is advisable to do an after, not only oversampling, you actually do an undersampling as well. So that based on your scenarios, but you may need to do both of the things simultaneously so that you can make a balance approximate. There is no thumb rule that you should do the oversampling or undersampling. There is no thumb rule. This is again data science scientist mind, that after seeing the data, you need to there will be an how much oversampling you want to do and how much undersampling you need to do to make this two bar little closer to each other. Okay, story form. Sorry, I could not understand that. Yeah, it's kind of a scaling. We don't call it as a scaling because it's not like you are not trying to scale that particular variable. You are trying to repeat the rows to make it oversampling or removing some rows to make it undersampling. You can do that. Nobody is stopping you to apply machine learning model before comparing the accuracy, but that may waste of time for you, or maybe which machine learning algorithm you'll do. There are hundreds of machine learning algorithms in the market or in the books, right? Which machine learning you will apply. This particular process, what I'm doing will help you to identify which kind of machine learning algorithm you want to apply. Giving bias result. Okay, we'll talk about it to the metric part. Let's jump into that. Okay, this is what we talked about. Forget about the right hand side. Let's concentrate on the left hand side first. Data preprocessing, we already covered what kind of data preprocessing we need to do. Next part is, after all this processing, even the undersampling and oversampling also comes under this data preprocessing. Just a question to Sneha and Srinivas. I'm not sure we'll be able to complete within time. Can I get another 15 minutes or it's a hard stop?
Sure, Somnath, you can extend.
Sure. Because I really want to address the questions I'm getting. Although because of this thing, I'm not able to addressing all of them, but I really
that's
want
fine.
to.
That's fine.
Okay. Thanks. Coming to the model training, as we discussed in the beginning, that this will be a classification model. There can be hundreds of classification models we have. What kind of classification problems you want to apply? That's what we will discuss into our right hand side of the slide. Coming into the validation and the hyperparameter tuning. This is tricky because every model has their own hyperparameters. I will, as beginning, somebody requested that let's not go into the deep of the ML model. I don't want to go into, because we only have half an hour, maybe in next session sometime. But every model has their hyperparameter. But all this purpose is giving you an best accuracy and stable model. What I mean by stability? Stability means that I'm applying the model today, it is giving me an 80% accuracy. Tomorrow I apply the same model with a little bit of different data, it gave me 30% accuracy. A day after tomorrow I apply the same model, it is giving me an 60% accuracy. Can I trust the accuracy of this model? No, because every day it is changing, right? So that's the instability of the model. So our hyperparameter tuning, your model selections, your data processing, everything is one goal: best accuracy with stable result. Best accuracy is not enough. You are getting 99% accuracy, but next day you apply, it become 20%. That is useless. So that's why you need to have a stable and the best accuracy on that side. Coming into the final model selection and the prediction, as I told, that from the list of 100 of algorithms, based on your understanding, based on your data pre-processing, based on your oversampling and undersampling technique, you need to choose which model to be applied. I'll give you some of the example. Not everything can be covered without the data, because whatever I am talking about is without the data. We talked about the data, but I don't have any data with me, right? So it's not possible to do that. But I can give you certain example where one model can be beneficial to other. Now let's talk about the right hand side. I'll take probably 1 minute of pause in case you have any doubt till now. Okay, great. Okay. Okay. Now coming into the logistic regression. Think about your data is skewed like this. And after doing oversampling, undersampling, lot of struggle and all of these things, okay, answer to your question, this is the steps, by the way. This is the overall 5-step process that as a data scientist, you should follow. And every step, probably there is some sub-step, but this is the very mota step of this one that you need to follow, 5-step, and to get the final result. It can be forecasting, it can be prediction. That's why I written prediction here. It can be forecasting because it's a very generic one. Yeah, EDA comes under data pre-processing. That's why we covered into one slide. EDA, your data engineer, your feature engineering, feature selections, all comes under data pre-processing here, and then model training, all of this thing comes. Okay, coming into the logistic regression or the random forest or the gradient boosting neural network, these are very big, good names. But if your data is skewed in terms of like this, and after oversampling, undersampling also, as a data scientist, you are not very satisfied that your models are not very level in terms of, if you, after doing all of these things, you found that 70% of your data is still no, and your 30% is still yes, but your oversampling doesn't make sense after a certain time. You are probably repeating too much of rows to do the oversampling, or maybe you are cutting off too much rows from the undersampling. So you stay into 70-30%. Okay. Now that 70-30% of this one, you really cannot apply a statistical model. So logistic regression is statistical model, where it follows statistical theories, statistical equations, and that's why there are certain reasons. I'm not going into that technical part, but certain reason with a skewed data, you should not apply a statistical logistic regression kind of model. Thumb rule. Okay. Now coming into the random forest. If your data is a kind of a hierarchical data, think about hierarchical data in terms of you have a data from a employee database that one person is director, then senior manager, then manager, then data scientist, then senior data scientist, then scientist, something like that. Hierarchical data, and every level has their own kind of details like salary, designation, joining date, if that person left, then resignation dates, all of these things. That kind of hierarchical data. Tree-based model, like Bayesian tree, random forest, or maybe gradient boosting. This type of model are good in terms of all this hierarchical or the panel data. But that doesn't mean that it will not work into other data points. This kind of an checklist for you to try this kind of model first. That doesn't mean that you will remove this kind of model if those kind of data are not coming. Okay, hope you understood this part. Little technical but tricky. Any questions? I'll take maybe 2-3 minutes more into this slide, because this slide has a lot of details and very important. or we lost interest already? I'm not getting any questions. Okay, fair enough. I'm assuming that there is no question. Okay. Next, neural network. This is very fancy name, and I think in your data science world, if you are already part of that, steps fixed for all cases or vary case by case. These are probably starting point. The person probably 1 hour of session can give you only the starting point. That these are probably a starting point as a thumb rule for any kind of problem, as a classification problem or regression problem to start with. But when you go into dig more into the data, you will probably find out a lot of different kind of scenarios you need to solve. Techniques that we apply for model design. Yes, the right hand side is technique we apply for a model design, that end to end 1 to 5. That's the model design technique. Yeah, testing part we'll talk about next slide. Yeah, gradient boosting. Not sure. Do you guys understand the difference between a bagging algorithm and the boosting algorithm? If you not, let me explain. Very maybe in layman language. That bagging algorithms are example is random forest is a bagging algorithm. Boosting algorithm is gradient boosting or XGBoost. Probably you heard of XGBoost name a lot of time. The bagging algorithms are kind of an ensemble algorithm. It is trying to find out that okay, let me give an example of human being. That I and you guys try to find out which is fraud and which is non-fraud. I told it is fraud. One of you told that person name is maybe name A, told it is non-fraud. Person B told it is fraud. So actually the fraud own, because 2 people out of 3, 2 people told that it is fraud and 1 person told it is non-fraud. So fraud own, it is the bagging problem. It is because it is actually trying to combine different kind of trees in parallel. I am not influencing person A or I am not influencing the person B as well. So they are individually saying that somebody is saying fraud, somebody is saying non-fraud, and I'm saying fraud. So 2 people told fraud, 1 person told non-fraud, so it became fraud. It's kind of a voting problem. That yes, majority it takes. That's the that's how a kind of an bagging problem or a ensemble problem works. That I did not influence person A or person B, nobody influenced me, so it became like an and everybody collect together and found out a result that okay, 2 people told fraud and 1 person told non-fraud. Similarly, how any kind of vote or election happen, that's a bagging problem. That one bag, everybody put their item and nobody knows what item is going to come out, and everybody together and find out one result. So that's why you call it as a bagging problem. Random forest. Do you know why it is called as forest? Any okay. Yes, collection of trees. That's the thing. That think about now. I gave you an example. Me, person A, person B. I am a tree. Person A is another tree. Person B is another tree. We all 3 together became a forest. And randomly we are choosing that okay, this three tree will decide that which will be the result. That's why it call it as a random forest. And because inside the forest we are choosing the trees and combining and ensembling and providing a result. So that's why it call it as a random forest. Okay, how we are a tree. Okay, that's a decision tree reason. I'm not going into that part. When you read decision tree, you'll understand that why I'm calling it as a decision tree. When I'm calling it as a tree. So gradient boosting. Now think about, I told that it's a fraud. Same example, me, person A, person B. These are the 3 trees or 3 people are going to decide. I'm saying this is fraud. I am maybe 70% sure, 30% I'm not sure. I'm providing that the same result to the person A. Actually, I'm influencing the person A, right? Because I'm providing the result to the person A and saying that I'm 70% sure. Can you improve a bit and make it 80%? person he evaluate and say that yes, it can be 80% sure, and I did some of the tuning and it is 80% sure. Then it is providing the same result to the person B and say that we both together decided that it is 80% sure and it is fraud. Can you do a little bit of tuning and say that it can be 90% or not? Person B told it can be 90%. Yes, let's make it 90%. So what is happening now? It's a serial method instead of the parallel method. Random forest was parallelly we are deciding, but it is now kind of a serial method. Everybody is influencing each other and coming to a conclusion and trying to increase the accuracy every time. Now, there can be pros and cons for this. Think about it. That pros is you will get a high accuracy because everybody is trying to increase the accuracy the first person told. I told it is fraud and 70% accuracy. When it reached to the person B, that person B told it is a 90% accuracy and it is fraud. Yes. So what is happening? That everybody is trying to make a point and trying to increase the accuracy by removing the error. So that's why it is increasing. Yes, boosting is method to improving the previous accuracy result. But what is the cons? If I was wrong, I told non-fraud to a fraud, all the person A, person B will say yes, this is correct. So there is a chance of this one that there is a overfitting. I don't want to use this name, but overfitting means that you will tell something, but you will be so confident onto that one, but it may not be right in the practical ground. So that's the cons you will have into the boosting. Bagging in the same term that nobody is influencing each other. Okay, let's keep the last 15 minutes for the question. I'm not able to see all the questions now. So bagging is on the other side that it will give you probably a lower accuracy than boosting, but the accuracy will be much more stable than the boosting because it is randomly selected and nobody is influencing each other. Everybody is doing their own work. So that's the reason. Okay. Now let's give maybe 1 minute time to answer. It's like type 1, type 2 error. Yes, that's the thing. Parent boosting. Yeah, that's a funny answer. Our parent discuss about career with relatives. Let me see if there is any. It's like a chain of probability, kind of. Yes. Same as clustered sampling. No, random forest is not clustered sampling. Cluster is a different thing. Random forest is a where you are not going to influence each other. It's a parallel processing happen with each of the trees. I'm not going into the why it is called as a trees, but each of the trees or each of the process will have a parallel processing, not as a boosting like a serial process. Okay, what else we have? Model accuracy versus performance. Yes, that's the thing. That's where the data scientist comes. That what do you want to choose? You want to choose model accuracy or you want to choose your performance on that. You have to balance this thing. You cannot choose a model with a accuracy of 90%, but there is a very high chance it will be wrong. So that's where your data science mind comes into picture to choose the best model for your purpose. Best model with a stability and better accuracy. Not the best, maybe. Okay. What else? Is random test or gradient, not test, random forest. Gradient boosting is different technique that apply on the model. Yes, that's a different technique, different algorithms altogether. Random forest is a different algorithm. Gradient boosting is a different algorithm. I'm not sure what you mean by the get to know this model. There are a lot of papers, a lot of books to talk about this models, how this model works, to technique about these models. You just go into, you don't need to do any Coursera or something like that. You just go into YouTube and search for the random forest. You'll get a lot of courses there as well. How to select the best model? That's a good question. I wish if there is any thumb rule. There is no thumb rule. That's why the data scientists exist. That's you have to choose based on your data, understand it, and provide the result which are stable and the performance. Okay, moving ahead into the next slide. You can suggest any books. Okay, book size and probably we can talk later. There will be a lot of books there, but I think one of the things, if I remember correctly, back in Black was one of the book which was a statistical model purpose, not as a machine learning, but there was some machine learning model also. Okay, I got some of the questions that how to validate that, right? That how do you know this is a good model or bad model? So obviously I cannot just see that model and say that, okay, this is a good model or this is a bad model. So to do that, what we generally do, and I think you guys already aware of this thing, but let me repeat if you are already aware of, that we generally divide the model into data, sorry, not the model, data into two halves. One is the train and one is the test. Train is maybe 70%, 80%. There is no thumb rule, but at least 70% we can generally tell that 70%, 80% of data is train and 20% of data is test. You split the data into two half, and you are talking about, you are just trying your model or you're training your model into train data. And when the model is ready, you try the same into test data. Okay, that we call it as a validation of the model. You can call it as a validation data as well. There are people generally take multiple test data. I'll talk about that thing later. But this is how we train the model and test it onto some other data. Yeah, there is again, that's why we are doing all the pre-processing from the beginning, that to understand my data is correct or not. Even if your train data is correct, your test data is not correct, it is actually going to provide you a wrong result, or result you will not able to trust it. So that's why the train and test data is, we need to make sure from the beginning, the data pre-processing, feature engineering, feature selections, everything comes into this train and test. And not sure you guys understood this train and test concept, but think about your exam. You read some books and you read a lot of different books, and you try to cover 100% whatever is going to come into your exam. That's, you are training yourself. Think about, you go into exam, that's totally an unknown place. You don't know what kind of questions are going to come, and if you read properly, you read everything possible, then there is a high chance you will provide 100% in your you will get 100% in your exam. But maybe there are 90% you know into that exam, 10% you don't. So your accuracy will be 90%. Exactly the same thing. Train is your reading the books before exam. Test is your unknown data to testing your model. If model already seen something related to the test inside the train data, model will provide you 100% accuracy. But if model have not seen something which are already in the train or already in the test, then in the test it will provide you some less accuracy. Okay, sure. Then coming into the splitting. Now you tried with one test. You maybe that's a fluke. You got a 90% accuracy. That may be a fluke. How to make sure that it's not a fluke? Giving the same example, that when you are going through your 10th or 12th in your childhood, that how many you gave first pre-test, then you gave test, then the 10th exam comes. Similarly to that, there are multiple tests you give, then only people sure that, okay, this person is intelligent or this person is good. Can I trust this person in my job or something like that. Similarly with the model, that you don't test with a one test data, you test with a multiple test data. If it is a kind of a time series kind of model, that for example, you applied on a sales data, which are starting from 2008 till 2023. You cannot break those data and choose any test data from your model. Then you need to do something like on your screen, that it will be splitted into a different test data and applied. But if you are having kind of a fraud data, you can actually take random sample from your data, like a 20% of the data, and then you can do this. Yes, that's called cross validation, because you are checking it with a different test data. We call it as a k-fold. or we call it as a rolling. If it is something like this, then it call it as a rolling. If it is a random sample, we call it as a k-fold. K-fold means k is the number of test data you want to check. If it is a 3, then it is 3-fold. 5, 5-fold. K is the number. So k-fold. That is one. Now hyperparameter tuning. I'm not going into little deep. This is little tricky. Let's skip this part because there are a lot of different techniques will come into picture and we don't have that much of time. Metric. We talked about different metric. I'll share this slide with you, and if you go through just this 4 or 5 things, you will understand what those metrics are. But let me try to give you a little bit of clue from this table. Okay. This table is called it as a confusion metric. Okay. Oh, don't ask me why it is called as confusion, because maybe it's confused too much. But it's like if you are having non-fraud here, and if you are having non-fraud here, if you are fraud, this is predicted and this is actual. If something is non-fraud and model is also saying this is non-fraud, then it's true positive. Something is fraud, model is saying non-fraud, then it is false positive. Similarly, false negative and true negative. So as you understood, this particular thing, true positive and true negative, is your accuracy for this model. Okay. Yes, there is the type 1 and type 2. I don't want to, because in the beginning somebody told that don't go into the dip, so I'm not going into the type 1 type 2 error, but this is what the type 1 type 2 error calls. Okay. Now precision is if your target is true positive. For example, you want to find out what are non-fraud. Even if somebody is saying there are true negative, you don't care. You want to increase your true positive only. Then this precision is much more important for your model. It depends on the business problem. Do not go into the by default what is need to be taken, but depends on the business problem. That if you, for your case, for our case, what was the problem? I want to find out what are frauds. If there is a fraud and I don't want to miss them, but if there is no non-fraud, I can actually doubt them. That is okay. If there are 100 of customer who are, there are 100 transactions, there are 20 transactions who are non-fraud, but I told them fraud and I actually scrutinized them, still okay. But if there is one fraud, I cannot miss that one fraud. So for my purpose, this true negative is much more important than true positive. That is recall. Yes. Okay. So for these cases, please go through this one. I think slide can be shared. Please go through this one. This is very easy. Just you need to understand from your mind, from your business problem, for your business problem, what is important, what are not. That's all. Okay. Okay. Now think about you did, and this is I think the last slide for this. From till now, we built our model, we validated our model, we tuned our model, we found out the accuracy, everything is done. But if we are not creating this kind of pipeline for our user, it's not possible for user to use this particular model because they don't know data science, they don't know, they are a business people, they don't know data science, they don't know model, and you cannot expect them to understand as well because that's your job to do that as a data scientist, right? So that's why this technique are needed to stabilize your model. Whatever we have built till now, let's deploy it. How to deploy it? First, you need to understand what is inside the current system. Probably in the beginning, if you remember, we talked about they already have a rule-based fraud detection technique. So for that rule-based fraud detection technique to be replaced with our technique, we need to understand the complexity of the system. If there is any complexity to replace that algorithm, is there any dependency for this? We need to collaborate with them, then implement into this. We need to test into the system. Probably it is working into our system, but whenever we are deploying into their system, it is breaking. That we need to follow step by step. Okay. I'll quickly finish this monitoring part, probably 5 minutes time, or probably 5-10 minutes for your question answer. But the monitoring part, now think about that. This month is September. Till September data, I trained my model and I deployed into client system. October, there is a new pattern data came. You remember the trend and pattern we talked about in the beginning? Am I going to check again all this EDA, data processing, and everything every time to retrain my model. That's not possible because you already delivered the model, you already deployed to client system. Client will not allow you to do that. So what we can do? We can track the model purpose. That every time I will probably set a cutoff that if the model accuracy is dropping by X percentage, maybe 5% or 10%, it will raise a concern. With the performance metric, it will raise a concern to the client and or maybe the data science team that, okay, this much of deviation is happening. This much of deviation is happening. Should I do anything or not? Or should I just ignore? After a certain time that, okay, if I'm seeing my recall value from the last slide, my recall value is not dropping, my precision value are dropping. I don't care. Let's consider on recall value. So I thought that recall value is dropping. Then I need to be concerned. I need to find out why the recall value is dropping. That's the recalibration problem, that we need to find out why the recall value is. My data trend has dropped, or is my total data has changed, or something happened, or maybe my model was not as good, model was not stable. So that's why it was happening. So that's where we need to leverage the insight and find out. And as I told, till this point, your involvement is not needed because this should be automated into your system. It should be deployed into your system and automated. Here, if you see there is a problem, then your data science team comes into picture and they will be active and they will try to find out if there is a problem or not. If there is a problem, we will improve. And slowly it will improve, and suddenly you will start to see that there are not that much of drop happening into your accuracy. So that's how the total end-to-end deployment happen and the monitoring happen into real world scenarios. I think that's all from my end. Let's shoot your questions. Yes, that's the MLOps, correct? That's the MLE and MLOps part. Without this, I feel, maybe I'm wrong, I feel the data science problem and data science solutions are not that useful until unless it is actually value adding into your system. Okay. If you have any questions, please start typing. Maybe 5-10 minutes. Sneha, Srinivas, hopefully it's fine if I'm taking another 5-10 minutes just to answer questions.
Sure. Yeah, you can go ahead.
What we provide business as a okay, this is too fast. Let me read first. What we provide business as a data scientist. Sorry, I don't know. I understood this thing or not. As a data scientist, what we provide is till this point on your screen. We provide a model which works in terms of validation, hyperparameter tuning, and the metric, which works, which have been tested properly, and that will solve my business problem, fraud or non-fraud. That's what we provide. Model object. YouTube channels, that's difficult to provide you now, but there are multiple. Can you give me any scenario where persistence score is important than recall score? Let me think. Okay, let me give you the one scenario where precision score may be as important as recall, where doubting somebody is expensive in terms of, if you are thinking of that a person, and I'm going to give you a very bold scenario, if a person is a terrorist or not, think about that. If you are identifying, and I read somewhere that China implemented something where from the facial expression or facial view, they are identifying that person is terrorist or not. Now, it is important to find out terrorist, but it is also important to not to doubt the innocent person. You cannot doubt everybody that, okay, that person is terrorist, and let's interrogate that person. So your precision is as important as your recall. You have to balance into this call, into this particular taking calls, that What is more important for you? Is it finding out the terrorist, or is it like, let's doubt anyone, I can doubt anyone in the country? Depends on that. So this is probably one of the bold example I just thought of my mind, where the doubting your zero value also much more important. Okay, AV InBev. Don't think about AV InBev. Think about any product company who are building product, like HUL, Hindustan Unilever, they are building product. Your Reliance building product. Tata, there are a lot of Tata companies are building product. Tata Steel, Zudio, a lot of other companies. What they are doing, they are selling to the end customer. Similarly, think AV InBev selling beer to the end customer. What can be the business problem for this? That I want to increase my sales. Everybody want to increase their sales. Everybody want to increase their profit. What they can do? They can market it better way. So they can do a marketing in a better way to increase their sales. They can identify their potential customer, promote. Correct. They can promote properly. Data science can be used, or data science is vastly used into the promotions marketing world, into any product companies, not only available product companies, any product companies, they do. Think about another product company who are doing supply chain. HUL probably is the most strong supply chain company, who are their supply chain backend is very strong. Now, what to send at what shop, when to send that particular product to what shop, so that my product sale will increase, but on the other hand, that shop will not store my product after a certain time as well. It will be sold in a frequently manner. So I need to know the demand for that particular location. Demand prediction or supply chain management is another problem, or data science problem, in any product companies, including AV InBev. Hope that answers. No, not only marketing team. I gave you two different examples. One is for the marketing team, one is for the supply chain world. There are different teams. You think of any problem can be solved, or data science can be applied into that problem. Any business problem, sales prediction, yes, data science problem. Supply chain management, data science problem. Inventory management, data science problem. Marketing, data science problem. Pricing, I was in a HP team, HP pricing team. I was data science manager there. Our team responsibility was to define the correct price for any HP product. So it can be printer, it can be monitor, it can be keyboard, it can be mouse. Any HP product, you define what will be the correct price, so my sales will be highest, or my revenue will be highest. That's the problem. Can you share life of a data scientist of the company? I mean, data scientist, what I just told you till now, that's probably a 5-minute trailer for a data scientist life. That's why we do. But the maximum data scientist life goes into this data, this part. The minimum goes into this part. Modeling is a small part. Data creating, data processing, feature engineering, all of these things are majority of the part. Let me go through some of the questions. Okay, Amazon is a probably most vast data science use cases you can find in Amazon. You go into data science, you go into Amazon portal. In your mobile, you go into the app, you can see that people are buying this as well. Recommended product for you. Do you really think that a human person is giving you? No, that's called your recommendation engine. So that's the recommendation engine is providing you based on your pattern, based on your buying pattern. If you did not buy anything, then somebody else like you has bought something to find out the pattern. So that's the one of the most popular use case. But whatever I just told, supply chain management, fleet management, with your sales prediction, price prediction, everything, I think all of these things are Amazon is already applying. PPT, I think Sneha can comment. PPT, you can get it or not. I think you can. But yeah, Sneha can comment on this.
Sure. We will be sharing after the session.
Yeah, sure. Data scientist, you handle all the steps for prediction, just one step like the No, no, no. As a data scientist, I told everything, whatever I told you is everything handled by data scientist. Majority of the part is data processing, feature engineering, and everything. Little part in the modeling. If you are comparing, maybe 20% in the modeling, 80% of your life goes into the make a better data, which can give you a better result with the modeling. Without the data science doesn't make sense. Marketing, I just gave you, right? That think about that you want to give a discount. Let's take an example, Amazon Prime Day. Everybody is aware of Amazon Prime Day, right? Amazon Prime Day want to give an discount to their customer on Amazon Prime Day. That's a promotional activity, right? What is the best price you want to provide for a particular laptop? Okay, that's one of the promotional activity you should do. That what will be the best price so that my sales will be highest, but I will not go into loss. I will still be profitable, but my sales will be highest. I will get a lot of customers. That one of the promotional activity. You see, lot of people are these days putting TV ads, right? That's a promotional activity. But your ad are performing or not? When exactly you need to put the ad, so that one of the project I did for one of the media company back in 2017-18, that was like that TV ads. We are going to provide the TV ads, but at what slot? You need to find out at what slot, at what kind of program. It is a daily soap, it's a sports program or something like that. What kind of product you want to show that in the ad, so that you are going to get the maximum views. So that is also promotional kind of activity. About tell about the data analyst, sir, where their work. Data analyst, if you are calling yourself only data analyst, then sorry, this one is not working. Then till this point, your maximum of the things are working. Data scientist is kind of an package including data analyst. Data analyst, you can call it as a subset of data scientist. Data scientist comes into the model and everything. Data analyst will do the building the data, creating this one, maybe little bit of regression or little bit of statistical model, but maximum of the data exploration part. I'm not saying this is not important. This is very important. As I told, that data is your kind of a life for your model. So if you are going to get a better data, then only you can apply your model. So that's why the data analyst job kindly stops here, but data scientist will continue applying model and building those things. Job is offered to data scientist for this. Yes, job is offered to that. This is kind of an, you can contribute $1 million or you can make a loss for your $1 million to your customer as well based on your model. There, what are the ways which phrases are easily get? I would say the practice answer to this question, that the easily data analyst or business analyst job. I think it's practice. You need to do practice till the data, this part, that how to improve your data. There are a lot of testing you need to do with the EDA, data trend finding, features importance, all of these things you need to do. That's still data analyst part. Data scientist part will continue and do the model building, how the accuracies. There are multiple platforms in the market, Analytics Vidya, Kaggle, lot of different competition are going on. Forget about the competition. Take the data, follow the rules people are applying, apply on your data, and see that kind of practice. Reading books, going through the courses are fine, but practical world, you need to hustle with your data. Data analyst job, there are multiple tools. Start with our own Excel. People in the data science world, they use a lot of Excels. But if your data is huge, then probably some of the SQLs. If you are going ahead with the data preparations, any of the programming tool like Python, R, sometimes SAS, few people use SPSS, something like that. So you can use multiple tools and multiple this one. It depends on the company to company, but these are the tools in generic. If you want to do the project where Kaggle, go to Kaggle, you will get thousands of data sets. Just search for Kaggle, you'll get thousands of data sets there. Even Google has their own data platform. Search for Google datasets. You will get a platform, I think data.google.com, if I'm not wrong, or datasets.google or something like that. You will search your data, you will get from Kaggle or somewhere else a lot of data. UCI, yes, UCI you will get. How to improve knowledge about real life business problems. Look, I generally says, sorry for taking too much of time in questions wise. I generally says that think on your outside world, that what are the problems you are seeing. So whatever you are seeing the problem, it can be, there can be some business problem associated with this. Okay. Think about if you are going ahead with, you are traveling to somebody, somewhere, you are traveling to your office. You see that there is a lot of traffic jam, very popular in Bangalore, but a lot of traffic jam into this. Can data science can be applied into traffic jam if data has been provided? Yes, there is a, you can do a data traffic management with this. You saw a particular, maybe Zomato or Swiggy's delivery boy is traveling. Do you really think there is a concept where people can apply data science into the Zomato or Swiggy? There are a lot of data they have. Everything you are applying or everything you are putting order, it can be applied through the data science. It can be solvable through the data science. So to create that mindset or the domain knowledge, just open your eyes and ears. You will find out lot of data science problem there. You may not get data for this, but at least the mindset will be built that, okay, this kind of problem can be solved with this problem. This kind of problem will be solved with this problem. Think starting point. Is it a regression problem or is it a classification problem? Okay, classification problem. What kind of challenges I may face? There is a skew data problem. Okay, let's solve the skew data. What is next? I need to find out, okay, this is a bagging problem or is it boosting problem? Bagging problem. Let's apply bagging problem. That's how you will proceed with any of the problems. This is very basic, I'm saying, but there are different ways of doing things. Yeah, we could you please suggest something? Books wise here, I don't know. Books can be applied with multiple things. I don't know. Books wise, I can probably share some of the book details to Sneha. I can share some of the book details, but I would suggest not the books. Think about your practical world. Not only the books. Courses wise, you will get multiple courses into your thing. Okay. Could you please suggest books wise? Yeah, as I told that the case studies will do. Yeah, case studies you can. I can provide probably some of the data sets and case studies to Sneha and Srinivas. Which to the most important. I would say the data side most important tool is Excel. You need to understand that SQL if the data is huge. From programming side, Python. These days R also works, but not a lot of company works into R. So that is one. If you're not from statistical background, I'm also not from statistical background. My subject was computer science. I read statistics maybe back in 2008. Formal education of statistical never happened. Whatever I learned through the job, whatever I learned from the understanding. So if you are asking me, statistical background will impact if you are not trying to understand. If you understand, you can still do that and understand from this. Python is not so fluent. Can I be data scientist? One programming language is either Python or these days there is another one people are talking about. I forgot the name. Julia, I guess. Julia. Yeah. No, not PHP. Not PHP. PHP is kind of an web-based developer kind of thing. It's not PHP. Tableau, Power BI are visualization tool. So think from there are different steps. First, data. Understand Excel and SQL. Good enough. For the beginner, if you are going to the advanced, you need to understand a lot of Databricks and all of these things. But think about Excel and little bit of SQL. Next step is programming. That is modeling. You cannot apply modeling into SQL. This is very difficult, or not even possible sometimes. You need to understand one programming language. Let's take R or Python. Either understand R or Python. That is one. Next step is you did everything, but you need to explain somebody. You need a visualization tool. Either Tableau or Power BI. Don't target both of them. Tableau or Power BI. Power BI is free. You can apply Power BI. If you think that Power BI Tableau is too tough, at least understand in Excel how can you explain your model, or how can you explain your findings. That's also sometimes good enough. I generally, in my day-to-day regular life today, I'm not using Power BI or Tableau. Not needed, because my client or my stakeholder understand PPT graphs that I create with Excel. That is good enough. Why should I open Tableau? I know Tableau, but I don't open that much. So that's why don't concentrate on the tools. Every step, understand one tool, do good. That's all, and understand how and what you are doing. I think good enough. I think that's all. I already covered 30 minutes extra here. Sorry for taking too much of time. I think half an hour extra I took. So, Sneha, probably, hopefully, it will not disturb your schedule.
No, sir, that's fine. No worries.
Okay. Okay. Anything else? Anyone? There is not much problem on SQL. I don't know. SQL is good for data, but I never seen applying machine learning algorithm in SQL. So. Last question, salary. Okay. Not to which online platform is best practice. Practice Kaggle. Go Kaggle. You will get multiple analytics Vidya also good in terms of providing the data, providing the competitions. Forget about the competition and accuracy. You do your own race. You take the data, apply the model, and apply. Azure, AWS, there is no good or best platform. It depends on the company. So people sometimes ask Azure, sometimes AWS. For example, my current company, they mostly work in Azure, but last company, they used to work in AWS. So there is no correct or wrong answer into this. Yeah, ETL is the first part, the data pre-processing, right? You need to get some data transformations. That's the ETL. Pre-processing. That's the ETL. Okay, I think we had good sessions, and I will still continue to get this one. But yeah, I think we can close. We can connect into the LinkedIn. Let me type the LinkedIn ID. So you just, this is my LinkedIn ID, by the way. You can search with my name. That also fine. You will get. We can talk into this. Hopefully, it was helpful. Let me know if any other questions or anything. Let me know.
Yeah. Thank you, Somnath. It was a wonderful session to say. Nevertheless, so one of the best session which we had.
Thank you so much.
So guys, yeah, I think that you find this session very useful and a roadmap to how you need to plan about the things going forward. And also, like, yeah, you were asking about the PPT. That's good. We have
Oh,
taken.
not Jadhav. Okay, 1 second. They are probably connecting to somebody else. You search for
Sure.
this person. There's my name.
And yeah, guys, as I was telling you,
Yeah.
PPT will be shared with you in your career services module. So the link where you have joined, so it will be added below that. So need not worry about these PPT. So it will be added on your LMS. So don't worry about that. And also, yes, coming to the feedback part, guys. So this was one of the wonderful session, which you had attended to. So it will be better to give the feedback. And I keep on telling you, so feedback is the one thing which is very important. So please do not forget about that.
Yeah, I would also maybe some anonymous feedback or something like that. I would also want to know the reason behind is I was keen to share the knowledge. I That was a long time back. I used to take this one. These days, not that much of time, but definitely knowledge is. I feel that when I'm sharing, it's sometimes I also realize probably something I did not realize before. So yeah, thank you. Thank you for this opportunity and let me know in case something needs to be answered or improved.
Sorry, Gaurav, should I run test on this feedback topic? Uh, Sorry about that, guys. Yeah. So yeah, please don't forget about the feedback, guys. So it's very important. So I hope most of you have enjoyed this session and learn most of out of it. So mention the in the comments as well, so that how you enjoyed that and what you are expecting. So see, guys, the thing we always tell you about the feedback is that, so whenever something goes wrong, so you come back to the feedback, and whenever something goes well and which you enjoyed in the session, you forget to give the feedback. So that's not how things should be. So just make sure that you're giving the feedback to each and every session that you attend to.
Thank you, Srinivas.
Thank you, everyone. Thank you for your time.
You guys, thank you so much for making this session wonderful, each and every one of you, by attending and by taking the session both. Thank you, guys. So good night.
Thank you. Have a great weekend.